Hey everyone, I hope that you guys are having a great day so far. Today we are going to be talking about pressure, density, and temperature in Earth's atmosphere. We're going to start off with density. Density can be defined as a mass per unit of volume. In simple terms, density is how closely molecules are packed together. If you want to go back to previous science learning, you can think of a gas, liquid, and a solid. And remember how a solid's molecules are very closely packed together, whereas a gas molecules are more spread out. Molecules that are closer together equal a higher density. Density of the air depends on two things in the atmosphere: temperature and altitude, or height above sea level. If you look over on the right-hand side, you will see the first of what depends on there. Let me start over. On the right-hand side of the screen, you will see where we are talking about temperature and how it affects density. So warmer molecules have more energy and want to spread out. So you can see on the left-hand side of that picture, there's cold air, there's more particles or molecules taking up, so the cold air is more dense than the right-hand side of that picture where the hot air is. You can see those molecules are moving faster and more spread out. The second thing that determines the density of air in our atmosphere is altitude, or height above sea level. So density decreases with height. The higher you go up in Earth's atmosphere, the less dense the air molecules are going to be, the more spread out they're going to be. So you can look at the picture, which is a great visualization. You can see towards the surface of Earth, there's a lot of little dots. But as you go away from Earth's surface, you see that the little dots or the molecules spread out. The higher altitude means less air pushing down from above, and higher altitude also equals weaker gravity. Those are two reasons why density decreases with the height as you go up in Earth's atmosphere. So higher altitude means less air pushing down from above, and higher altitude equals weaker gravity to hold those molecules to Earth's surface. The next thing I want to talk about is air pressure. Air pressure can be defined as the weight of having air pressing against a given area. Air pressure at sea level is equal to 1 kilogram per centimeter squared. If you were to add that up, that would be over 1 ton worth of pressure pressing on you. But we don't crumble, and it's because air presses in all directions, not just down. So it's a little misleading to say that you're experiencing 1 ton of pressure, when in reality it's pushing from all directions, the sides as well as the top of you. Air pressure also decreases with altitude, and it's simply because there's less air molecules to push against you as you increase in altitude. And you can see that illustration over on the right-hand side. You can see those air molecules being very closely packed together at the bottom, but then as they increase in altitude, you can see they spread out and there's less of them to push against you, giving them less force to push against you. Now let's talk about temperature of the atmosphere. Temperature of the atmosphere depends on which layer you are located in the atmosphere. We do know, and something that you need to know is the simple phrase warm air rises. When air is heated up, the molecules want to spread out and they become less dense, which is what causes them to rise. Remember from a couple slides ago that when heated up, air molecules want to spread out. Cooler molecules will come together and become more dense, and cool air will sink. And that's going to be a very important concept to understand when it comes to talking about air masses in the near future. One thing that you need to know is air temperature is relative to the surrounding air. So when I say warm air, it doesn't necessarily mean 70 degrees. It could just mean warmer air. So when you say warm air, it does depend on the air surrounding it, right? You could have negative 30-degree air mass, but a negative 20-degree air mass is a little bit warmer. Okay, so we would call that the warm air mass. Now, those are obviously extreme examples. Warm air equals lower density, and cool air equals higher density. So warm air is less dense, cool air is more dense. Yep. Temperature of the atmosphere. So this is going to be extremely important to know. Air temperature does change as altitude increases, but it just depends which layer you are in. So in the troposphere, as you go up in the troposphere in altitude, the temperature actually decreases. And you can see on this graph to the right, you can see in the troposphere how the temperature is decreasing as we go up in the atmosphere. So the line is going to the left, or getting colder as we go up in the atmosphere. The stratosphere is the complete opposite. It actually gets warmer in the stratosphere. And that simple reason is the ozone layer absorbs some of the sun's UV radiation, causing it to heat up. So you can see that the line changes direction when in the stratosphere. The mesosphere is actually the coldest layer of the atmosphere, and the temperature decreases as you go up in the mesosphere. And then the thermosphere, the temperature increases again, and the thermosphere actually becomes the hottest layer of the atmosphere. Okay. Sorry. What's next? You are going to read pressure and density of the atmosphere, which is found on Canvas. You are also going to read temperature of the atmosphere, found on Canvas. And then you are going to complete the atmosphere basics review formative that can be found on Canvas. That formative review is going to be collected for a grade, as well as it will review the past 3 days of information. So lesson 2.1, lesson 2.2, and today's lesson 2.3. Once you complete that, then you can have a great rest of your day.